Hello everyone, a very good morning to all of you, dear authors and invited guests. A very warm welcome to technical session 2C. Myself Yashita, and I'll be your moderator for this session. I'll make sure that everything runs smoothly. So, on behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 11th International Conference on Information and Communication Technology for Intelligent Systems, which is ICTIS 26. The 11th edition of the conference is being organized in a hybrid mode. So, the physical event will be held tomorrow in Bangkok and Thailand, while the virtual session are being conducted via Zoom from 9th to 11th April 2026, where people from all over India as well as many from other countries are present with us. So I hope you all enjoy today's insightful, knowledgeable, and interactive sessions. So in this session, we will be having 10 presentations. Each presenter will be given 10 minutes for presenting, followed by 2 to 3 minutes for question and answers by the session chair. And also everybody participants are also allowed to ask questions. So if there are any question from the participant side, you can also ask them. Let's make this session interactive. So I will give a gentle reminder at the 9th minute mark just to help everyone stay on track. So also small request to all the participants, please stay connected with us till the closing remarks. We promise it will be worth it. So if you have any queries or updates, feel free to drop them in the chat box anytime. So before we begin, I would like to introduce to our esteemed session chair. So we have with us Dr. Junali Jasmine Jeena, who is an assistant professor in the School of Computer Engineering at the Kalinga Institute of Industrial Technology, Odisha. Her research interests include machine learning, soft computing methods for pattern recognition, and evolutionary algorithms for optimization problems, data analysis, reflecting her focus on developing intelligent and efficient computational solutions. So, ma'am, I request you to share some quick welcome remarks for today.
Thank you. Thank you for introducing me and for having me here in the conference. So, in today's world, after the COVID, especially, we have started doing this hybrid mode. It's good if we are attending offline. So, takeaways in that case are definitely different. But those who cannot make it, definitely being hybrid and online, sharing the knowledge and sharing different researches and also the product based or development, whatever, anything in the nascent stage, we directly don't generally don't go for the journal and conference. That's why gives a very good platform to discuss the things, to discuss some new technologies, some new researches. So I hope this session will definitely help all of us to have some great takeaways, and we'll have some brainstorming ideas. And yes, so I'm also looking forward to have a great session. So all of you, all the best. Thank you.
Yeah, thank you so much, ma'am. So let's move on to the first presentation for today. So we have Al Johara Aldej from King Saudi University to present his work titled as A Case Study of TikTok's AI-driven recommendations, transparency, privacy, and mitigation strategies. So, Al Johara, are you there in the meeting?
Yes, I'm here. Can you hear me?
Yes, yes, yes. Hi.
Hi.
So can you present your screen? Wait, I'll share.
Just give me a second to share
Yes,
my screen.
yes. May I know how to pronounce your name? It is a very unique name, though.
Thank you. So, is it showing?
Yes, yes, it is visible. So I asked how to pronounce your name. It is a very unique name. Never heard of it.
Thank you. First, good morning, everyone, and welcome. My name is Al-Johar Al-Da'ij, and today I'm honored to present our research paper. This work was completed in collaboration with my teammates, Lay, Sarah, and Dalia, and we are excited to share our research with you today. First, imagine opening the TikTok app and starting to scroll. Minutes pass, then a whole hour goes by without you even noticing. Have you ever wondered why this happens? Who controls what you see, you or the artificial intelligence? On TikTok, it only takes 3 videos for the app to understand your preferences and start shaping the content of your day, even your week. This is the focus of our research today, how recommendation system affects our privacy, transparency, and digital experience. Just a second. TikTok is a popular app that uses AI to personalize user experiences by analyzing behavior like likes, views, and comments. It's a global success, especially among teenagers, comes from short videos and accurate recommendations. However, it is extensive data collection and lack of transparency raise ethical concerns about the privacy and its influence on younger users. Before diving into the case study we used to study it, we used a qualitative case study, which was just a second. We chose TikTok because it's a major short video platforms where AI recommendations strongly influence what users see and interact with. To study this, we combined a structured review of academic and credible public sources within analysis of observable TikTok features such as recommendation, explanation, content preferences, tools, and the privacy-related controls. We did not try to analyze TikTok hidden algorithm directly. Instead, we focused on the user-facing side of the system and evaluated through the lens of transparency, privacy, and governance. This allowed us to identify ethical risks and propose practical recommendation. Having explained our approach, let's take a closer look at the case. We focused on a TikTok AI-driven recommendation system, especially the For You feed. We selected TikTok because it's one of the most influential short video platforms where AI plays a major role in deciding what users see and engage with. The system relies on behavioral signals such as watch time, likes, comments, shares, and skipped videos to personalize content very quickly. This makes TikTok strong example of how recommendation system can shape user attention and digital experience at scale. We also examined the main user facing tools related to recommendations, including why this video not interested, feed refresh, and manage topics. These features makes a TikTok an ideal case for studying how AI recommendation systems raise questions about transparency, privacy, and control. With the case described, we can now discuss the challenges involved. Transparency means the user understand why they are seeing specific content. However, on TikTok, recommendations are not clear, a black box. Users don't know which behaviors have the most impact, such as watch time or likes. Even with the why this video feature, it to provide only a simple explanation and doesn't effectively help users control the content. Uh, then what the result? Reduced user control. Without understanding, there is no real control. TikTok collects a large amount of data such as watch time, user interaction, interest. This leads to building a highly detailed user profiling, the possibility of inferring sensitive information about users. The problem, users are often unaware of the extent of the data being collected and how it's analyzed. Now we have covered the ethical issues. We can discuss the key insights and the lessons from this study. The major ethical issue in this case is not just personalization itself, but invisible influence. TikTok does not only recommend the content, it shapes what users see, engage with, and sometimes even believe, without making that influence fully clear. Fully clear. The first concern is the transparency. Although TikTok offers tools like why this video, these explanations are still limited. So users may feel informed, but they are not always truly in control. The second concern is privacy. TikTok relies on constant behavioral tracking to personalize content very quickly. This improves relevance, but it also creates continuous profiling that users cannot fully see or audit. When we compare TikTok with platforms like YouTube, Instagram Reels, and Facebook, we see the same pattern. AI systems optimize for attention and engagement. But this can reduce a transparency, weaken user control, and increase the spread of harmful or misleading content. So this is not only a TikTok issue; it is a systemic issue. Engagement driven platforms, and this is where a governance become a critical if platforms mainly rewards watch time and retention, then the algorithm is simply doing what the system was designed to reward. These are a few recommendations we believe could help tackle this problem. Improving transparency, clear explanation of why content is shown, clarification of the factors that influence recommendations, giving users more control, simple tools to modify recommendations, ability to reset the algorithm, protecting privacy, reducing unnecessary data collection, simpler privacy settings, and at the last, governance, minimizing the spread of misinformation, monitoring algorithmic explosion. Finally, we come to the conclusion. TikTok provides an engaging and highly personalized experience, but this advantage comes with important ethical challenges. Therefore, achieving a balance between personalization and privacy and transparency is the key to building safer and more fair platforms for users. The goal is not eliminate personalization, but to make it more transparent, responsible, and respectful of user privacy. The future of artificial intelligence is not only about smarter systems, but about more responsible ones. Thank you for attention, and we hope you enjoyed our presentation.
Yeah, so Junali ma'am, are you willing to ask any questions to her?
Yeah. So, what do you think are the main limitations of the work, or the main challenges that one may face while going with this work?
That's a great question. Let me take a moment to organize my thoughts before I answer.
Okay. Okay, fine, not an issue. We can proceed to the next presentation.
Okay. So next up we have Sonali Gaikwad ma'am. Are you there, Sonali ma'am? Let me check once. No, I think she's not there, so we will take her later. So next we have Bharti A, who will be presenting his paper titled as Clinical Risk Scores Demonstrate High Discrimination for Middle Cerebral Artery uh, Aneurysm Rupture in a Single Center Chinese Cohort, a hypothesis generating machine learning study. So, Bharti, are you there in the meeting?
Yes, ma'am.
Yes, so are you ready with the presentation?
Yes, ma'am. I'm ready to share.
Yes, I'll stop. And we have to wrap it up in 8 to 9 minutes, okay? Be on point.
Okay, ma'am.
Please share your screen.
Is the screen is visible, ma'am?
Can you maximize the screen? Actually, half of the screen is visible, like maybe. Yeah. Yes.
Okay. Is
Y-
this visible, ma'am?
Yes, yes, it is visible. You can start.
Good afternoon to everyone. I am presenting my work, Clinical Risk Scores for MCA Aneurysm Rupture, a machine learning study. First of all, aneurysms are the blockage in the vessels, particularly middle cerebral artery in the brain. In the clinical problems are 30 to 40 percentage of high mortality in the aneurysm, particularly in the subcoronoid hemorrhage. This is making yearly risk assessment critical. Half of the survivors facing the disability and creating strong need of rupture prediction tools, and 30 to 35 percentage of aneurysm occur in the middle cerebral artery. So that's why the focus study on this MCA. Basically, the middle cerebral artery aneurysm prediction based on the three two clinical risk scores like phases scores and elapses scores. Phases are the population, hypertension, age, size of the aneurysm, and site of the aneurysm. Elapses scores and the explanation it is ethnicity, location of the aneurysm, age, and the size like that. The background of the research studies, which gives the three main questions. First one is phases are considered to predicting the MCA aneurysm, and second question is do morphological measurement adding the meaningful predictions in the clinical scores, and the third questions CFD derived parameters give the further improvement in the discrimination. Here I used the dataset CMHA dataset, which initially include the 150, 105 aneurysm dataset. Um, in the dataset, 71 patients are the ruptured patient dataset, and 21 patients are the unruptured. Uh, which is the mainly publicly available dataset for the research purpose. From the data set, 13 parameters detected in the clinical basic parameters like demographic, vital signs, and different parameters like heart rate, respiratory rate, and the 15 parameters are the clinical plus and phase score parameters, and the elapses score parameters, and scores plus morphological parameters are uh, aspect ratio of the aneurysm, and the size and the ratio of the aneurysm, neck width of the aneurysm. Overall, the 28 parameters detected in the aneurysm prediction. Methodology and validation, I used the two models in the machine learning. First one is logistic regression, and the second one is random forest. In the logistic regression, a maximum of 2000 iteration, and random forest 100 trees are used in the aneurysm prediction. The hyperparameters tuning is removed for the sample size in low sample size, and the train and test data set are 80 to 20 percentage, 57 ruptured and 16 unruptured, and the cross validation applied in the curve. Data pre-processing. In the data pre-processing, missing values were handled using median imputation and the categorical variables were encoded numerically. Standardization was applied with cross-validation folds, and we also addressed class imbalance handling with the class weights. These are the result overview of the machine learning performance. In the key results, adding the phases and elapses scores significantly improved accuracy 0.89 to 0.97. CFD parameters resulted in minimal improvement. Performance comparison. In the performance comparison, slightly more prediction rate rather than the clinical simple prediction model, that full model prediction having the high prediction rate. Bootstrap validation. Overall mean accuracy improved in the 93 percentage, and the sensitivity only the 14.3 unruptured aneurysm were missed. Future import independent test performance. Future importance analysis. Elapsed scores only the clinical scores achieve the 93 percentage of aneurysm prediction. In the future important analysis, there is the three important parameters used for the prediction of aneurysm. Elapsed scores placed on the first, and phases scores, and also alcohol consumption provided used for the aneurysm prediction. These are the calibration and overfitting curves derived from the machine learning. All models tended to overpredict rupture risk. The simpler clinical scores models have better calibration than a full model. Learning curve showed overfitting, especially due to the small data set. Critical methodological limitations are the study have several limitations like small sample size and class imbalance, single center dataset with a ethnic bias, simplified CFD assumptions, future redundancy between scores and morphology, and the lack of external validation is the main limitations in the data machine learning study. Also consistent work with real work. Location specific effect. Middle cerebral artery may be behave differently, different used in the communicating aneurysms. Clinical and clinical implications. Using the machine learning dataset, we phases and elapses remain the first line tools for the predicting the MCA aneurysm. CFD unlikely to add value. Morphological measurement giving the overlap of reduce the independent predictive contribution. In the study, future research directions one focus on the multi-center validation, like different region of patient dataset used for the aneurysm prediction. This increases the prediction rate, and the location stratified model, like different set of locations can be used for the aneurysm prediction. Advanced CFD methodology. Future work should be employed with the pulsatile flow of the CFD flow simulation. Also, 4D flow MRI dataset also used for the prediction. Longitudinal coherent design, which the long term of patient dataset used for the
Just a
aneurysm
quick
prediction.
reminder, Bharti, you need to wrap up in 1 minute. Yeah,
Okay, ma'am. I ended up the conclusion.
yeah,
This is the last.
yeah.
Phases and elapsed score, mainly high discrimination in MCA aneurysm prediction. Morphological and hemodynamic were added the values in accuracy in 0.02 percentage to 0.005 percentage. These are the references I used in the machine learning study. Most of the study focus on the phases and elapsed score, give the high prediction rate in the aneurysm prediction. Thank you. Is there any questions? ma'am.
Junali ma'am, do you have any
Yes,
questions here?
yes. So I just like to know why, like, you preferred for going over the traditional machine learning models rather than going for the deep learning models.
Here, ma'am, I used the traditional machine learning models for the only for limited data set size. Deep learning
Yes.
requires the most 1000 to 2000 like per data set.
Yeah.
We are using the small data set in deep learning. It's going to overfitting and prediction rate is low like that. Yeah, ma'am.
Yes. 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 Was there any data imbalance?
Yes, ma'am. Data imbalance is in the data set. Were 72 patients in the ruptured and 21 patient in the unruptured. Imbalance in the data set, ma'am.
Okay. So how you handled it?
I handled with the class imbalance method, ma'am.
Okay. Okay. Thank you. Thank you.
Okay, ma'am.
Okay,
Thank you, ma'am.
thank you for Bharati for presenting. So, up next we have Tirupati Rao Dokara sir to present his paper titled as Data Governance for Sustainable Artificial Intelligence. So, Tirupati sir, are you ready?
Yeah, good day, everyone. Yeah, thanks Ichita. I'm ready. Just give me a second.
I'll stop my sharing. You can start.
Yeah.
Yeah.
Let me know if you're able to see my sharing actually.
Yes, sir. Your screen is visible. You can start.
Okay, thank you. Hi, everyone. My name is Tirupati Rao Dokra. I'm the research scholar at Chandigarh University. I have published, almost 7 papers until now, and two are in the one of the top-notch publications like Scientific Research and the Discovery, International. And I am also working. I have around 27 years plus experience in the industry. I'm a chief architect and head of an R&D center in AI excellence, and we are at Scientific, one of the top product and platform companies in AI and Gen AI and robotics and physical. I work under the guidance of Professor Manisha Malhotra, who is an additional director at Chandigarh University for my PhD, which is in the final stages. So I'm just, I'm sorry, I forgot to turn on my camera. I'm just looking at how to do that. Just give me a second. Uh, am I visible in the camera? I
No,
don't
sir.
know.
You are not visible in the camera.
I'm just looking to up where the camera controls are. Just give me a second. I think I found it. Uh,
Yes, now
am I
you're
visible
visible.
now?
Yes, yes, yes,
Okay,
sir.
thank you. So, this paper is all about, the data because your AI is as good as your data. What, because the AI learns and understands as we learn from vision, voice, and other, senses in this real world. AI learns from the data. So the data governance is important, very, very important for sustainable AI. If you look at these are the, because now when you require data for AI, right, what you are doing, you are centralizing everything to a data centers. Because that is how you're getting the data from everything. There's two challenges. One is the cost of the data centers in duplicating the data, maintaining data, running the data only on the power side, if you see for the sustainable green side. It is 415, terawattage hours, which can power, around lakhs of people's homes actually. Why the data is already existing, distributed sense of the places. And this, introduces the security risk and many other things inside it. And who is governing the data? And there is a regulatory of localization to share the data. When people cannot put it up to centralized, command centers, and how AI will learn. AI can learn in a distributed way, okay, to a protected level. But where is the control? Where is the governance? What it is learning? Who is ensuring that the data is correct and complete? per organization on an average, if you look at the 4,500 companies, right, per annum on average in 2024, they are losing around 4 point. The cost to the data loss is around 5 million, 4.8 million per company on an average, per enterprise on an average. So sustainable data is not a choice or an option anymore. It is the mandate, is what I'm arguing in this research paper. So during my research, when I studied, right, there is a gap. So when we talk about the data centers, the data mart, we go for a model-based approach rather than a governance-based approach. We are trying to get it to a centralized location and we are designing the models, but we are not saying how we can learn it, who will approve it, who will ensure and certify the data is correct and complete in a way. That is totally missing. Where is an evidence for me to believe what the data I am learning through is being authenticated by the actual stakeholders and the people of relevance? That is not there. And there is a practicality of measuring, the outcome KPIs of this governance and all this centralization of data, how much they are getting, how much AI is learning, what is the value addition. There's no standardized framework so. Then I said, we should build up a capability, ontology or a taxonomy across the life cycle of the data. And I proposed the 6, evidence ground impact path, which will be visible of the organization will take. This sustainable, AI, data governance, the model, which, the impact model, which I am suggesting, will have a framework and, it will have eight hypotheses to be tested along with the treatment. So that is what the research is. It is completely testable with evidence and trustable model, not duplicating the data at a central control. Okay, how you can do it, manage with a distributed control, where AI can go near the edge and work with complete trust and control, where you're not getting every data and risking it. When you're getting the data, the cost is there and risking and more control flow is not enforceable. So that is where I'm looking into. The capability taxonomy, what I'm trying to suggest and build across the 8 major categories of decision right, accountability, data quality, representativeness, and modern lineage. Lineage is important. If you know where the data is originated, what has been done with it, because data get transformed, mix and match. When we get a value, how did we arrive at a value? Because it builds up in layers. Okay, so that is very important for you to take. And the privacy, consent, and the law, regulatory law. More the global world, globalization is turning into localization these days. So in this current era, the data governance becomes more relevant to, adhere to the local law, security and control, life cycle management, interoperability among the different entities, and what is the architecture? Because everybody don't want to share the data. The business secrets, the business transactions, but they cannot learn an AI because without AI is not sustainable. How do they share? At not reveal the details of the data, complying with everything. So that is the model which I studied and proposed and also implemented actually, and the sustainable measures and optimization, how this goes on. And this, the 6th impact, path, I said, quality and fairness, this will guarantee. Document and auditability, everything has to be auditable to check, it is there. It is not like, one level it is done, it is trusted, and other level verifies and, certifies, that it can be trusted, okay? And the privacy and security measures and interoperability and users, reusers and interoperability, somebody has done something, why should I do? To process the data, to fine tune an AI model, to a particular business function, we spend around $15 million to $20 million. And among that, the major part goes in preparing and processing data in the right way. So once an entity has spent so much, it is on computation, and computation has electricity and all those, the environmental constraint to which, we run this computation. If somebody has done it without revealing the data, somebody else can use it and we can monetize it. And your cost can be benefited because many people using not, pressurizing the nature. At the same time, your cost is also recovered over time. How do you do this? Okay. The life cycles of, how this, the rate, incident response, and how the changes, etc., can be minimized. Wastage can be done. What need to be learned? What need to be undone? What is absolute? So somebody has to govern and tell all these things. Otherwise, we are just going blindly and hitting up and getting that. Okay, and this how the sustainable, that complete, the instrumentation lead us to the outcome-based approach. So that is where in the mostly the research work. So basically, the data governance capabilities is emphasized and said it is no more an option and a choice, which is a mandatory. And how this help you to control the overall life cycle to give you the environment, social, and economical benefit. Environment, social, and economic. Environment from the side you are green mode, social from you are secure, adhering to all the privacy laws, and you are learning what you are acting like. Economic from there is no data loss. Okay, and it is not creating the reinventing the cycle, time to unfold. So that is where, this goes on. And if you come to these hypotheses, which I suggested for testing, right, they're basically, eight, hypotheses which we have, which can be tested, and they are three among the core model and the boundary conditions and enablers. So this hypothesis has been positioned in a way so you can test the outcome of the model and see how much it is helping you, what is the value addition can be in a measurable way. So that is what this thing gets you. And here are some of the KPIs I said under the three basic environment, social, and the economic, like, I have categorized, like, how much energy and all that, environmentally, the fairness index and privacy lineage, etc. for the social, and the AI, incident factors, laws, and the time to deploy, and the duplication, and an active policy compliance, for that, and all are measurable is what I'm saying, how they are measurable, etc. So that is where the entire, thought process of the researchers can, and the empirical validation design comes like this somewhere like that instrument development, cross sectional surveys, the confirmatory analysis, the case study, the triangulations. Okay, you can reconcile and verify that, and package the framework provides you that end-to-end where I found missing, and my research focused on that area. Okay, so this, the practical takeaways from this is, the for the practitioners, right? What they can do this model as, and for the researchers, how they can take this and do the further research, and what is the bottom line, the data governance, and its sustainable goals and the decision making life control. So this is where I'm saying, the practitioners could be from the industry, where they can use, and the researchers could be some we can take this to the next level. I've already, noted some of the areas where this framework can be further extended for better. My research can be taken forward and built upon. Okay, so that is the brief, thought process here. And this is the brief of, the data governance. And once this model is implemented, what I can say, you no need to go for a data centralization. Data centralization will be redundant. The cost, time, effort, energy to maintain this totally gone. And the distributed data can behave as a centralization with the complete governance at the edge, and intelligence can be shared and learned across with the data in the right plan. So this is where I, pause. And thank you for giving me the opportunity. I'm open for questions.
Thank you so much, Tirupati sir. I request Junali ma'am to share her question.
Yes. Sir, this your concept is only in the idea stage. You are still in the ideation stage, and
No, I built a complete framework and with the running in production and implementation also now.
okay. So, like, how you are ensuring the traceability, sir? Like, you have so many phases, majorly three phases you are having, and then within those phases you must be having so many sub phases, right? So how you are ensuring traceability within the phases?
Each value derived, right? For example, if you have the raw data, which is the facts, from there, data is processed and data is, combined for different calculations. So when
Yes.
you go to the each data, it will speak about the original raw data value, this value is dependent on, and how it has been combined and formulated to derive this value with a complete, the hierarchical tree like pyramid will come up to tell the
Mm-hmm.
truth about how this value has been derived. So this is where at a level of every point it is noted and tracked, and that is maintained as a meta model for every each value of the data.
Okay, so you were claiming that the data loss or the anomalies rate is low.
Very low, and it will itself speak about how good it is and how bad it is and where this is. So transparent model.
Okay, sir. Just one more question I have, the security aspects you told. So, which point you think is the most vulnerable point which needs to be taken care of, mostly, so that the overall security can be strengthened?
The most vulnerable point, from the security is the privacy and the regulatory with respect to the localizations, which is often missed, and the privacy is a challenge and
Yes.
the credibility challenge and the economic
Yes.
challenge.
Yes.
So the localizations and the privacies, governance, because every country has its own rules and regulations. So that
Mm-hmm.
aspect of how we in the land and participate in the data, that life cycle of sharing the data with all the
Yes.
controls is the one of the vulnerability managed. Okay, so
Yes. Yes. Okay. Thank you, sir. It's really nice work. Thank you.
yeah, yeah. So Yashita, there is a big emergency. I need to go. Can I drop off, please?
Yes,
If
yes,
you
sure.
permit.
As you have done with the presentation. Okay.
Yeah. Thank
Yeah.
you, ma'am, for your kind questions and
Thank you.
thanks for
Thank you.
yeah.
Thank you, sir. Okay, so our next presenter is Nishant Shah, who's presenting his work titled as Drishti, an Edge AI and IoT multimodal assistive navigation system for the visually impaired. So, Nishant, are you there in the meeting?
Yes, and
Yes. So, are you ready?
yeah, I'm going to
Yeah.
present.
So, I'll stop sharing. You can start your presentation. Yeah.
So is my screen visible?
Yes, it is visible. You have 8 minutes strictly. Wrap up within 8 minutes, please.
Okay.
Yeah.
So good afternoon, everyone. I'm Nisansa, and today I am going to present our work Drishti and Edge AI, an IoT multimodal assistive navigation system for visually impaired. So our Drishti is a multimodal assistive system that combines computer vision, sensors, and intelligent feedback system. So it uses YOLO V8 for object detection, ultrasonic sensor for distance measurement, for facial recognition. It's using KNN, and also for we are also using image captioning. So all processing is done on a device using Raspberry Pi 5. So there is no cloud dependency, and due to which the latency and privacy is maintained. So there is very low latency. So, bringing to motivation, the motivation behind this work uh, came from key challenges faced by visually impaired individuals. We analyze what are the uh, key problems that visually impaired person faces. They find difficult in understanding the surrounding in real time, the existing system and the previously existing system rely on simple one type of sensing that can be either the video or the facial recognition or any of the thing. So there was limited feedback system also, and most of them were using cloud-based solution, causing delay. So there was a high latency due to which they were not able to properly navigate through that. So already explained the problem motivation was that. So talking about the problem statement, current system are fragmented and they are incomplete. So some are only vision system that understand object but not distance. Some go through the ultrasonic system to detect obstacle, but they lack context. Many system are heavy and depend on cloud, due to which in a small device, in a small system, they are unable to work properly. And also feedback is often limited only to audio, and but in our audio or video, but in our case we are using both of them. So the system that we are proposing is Drishti. which combines object detection, distance sensing, facial recognition, scene capturing, as well as voice and haptic feedback. With the help of coin vibrators, we are also able to solve the problem of feedback to the user. Uh, so everything, all of the modules run on a single device using Raspberry Pi 5. So basically, it is perception plus awareness and feedback simultaneously. So for system architecture, it's like the input the inputs we are taking from camera, ultrasonic sensor, and microphones. And for processing, we are processing every of our inputs in Raspberry Pi 5, which is running the AI models. So the models that we are for object detection, we are using YOLO V8 Nano, and for facial recognition, we are using K nearest neighbor, and also for image captioning, uh, we are uh, we are using some system. Also talking about the output, we are able to give output in the form of speaker and coin vibrators, and for the messaging logs, we are also using MQTT services. Uh, so the uh, so the system workflows is like, at first we are initializing the models. When we start our system, we are initializing the models and the sensor. After initializing the sensor, we are powering up the Raspberry Pi, where every AI models are loaded. Then it captures the real time data. Using that real-time data, it processes the so for here, for now, the real-time data are images, because we are using it for visually impaired. So it processes the image, and the sensor activates, and it helps to detect the event. Like if it's a object, we get a generated object description in the form of speech, or if the input data is face, and if the face is recognized, then if we ask who is in front of us, then it gives us a speech output in the form of the name of the person. Also, if the person is unknown to the system, then it gives us the audio feedback that the person in front is unknown, and we can capture his image and caption him. And after that, whenever someone is in front, then he caps it the system captures his image, and run its in system, and try to find out who the person is. And similarly, it is giving us the uh, output. And also for certain emergency condition, it is triggering the alert system, that is haptic feedback it's providing. And it is in a continuous loop. Whenever we want to stop our system, then we can simply give command to stop in a audio form. So every commands here are audio form, which basically helps the visually impaired person to solve their problem. So the setup is like, we currently have made it in a simple cap like form, including camera, headphones, and Raspberry Pi. So for the setup, you can easily see the picture. Also, for the software, as already explained, we are using a YOLO V8 model for object detection, KNN for facial recognition, and OpenCV and Python for processing. And for communication, we are using MQTT services. And we also applied optimization technique like data augmentation and model quantization in order to uh, properly solve the issues. So the major contribution is that it is a unified multimodal system, fully on a single device, and edge AI processing. Real-time processing is quite fast, and the latency is quite low. Dynamic facial recognition system without retraining is also uh, available, and which are also available, and combined audio plus haptic feedback is there. So the results that we got is quite impressive if we compare with the existing solutions. So we try to observe with various existing problems, and we found that some of the existing solution was simply trying to solve a certain field, but our multimodal system is helping in a complete manner, so that so that a person can properly navigate and properly know about its environment. So the limitations for now is that it is quite sensitive in lighting condition, and energy consumption is high. And there is currently we are using a single camera, so the field of view is quite low, due to which some of the places it's not able to uh, see, and it is still finding some problem in navigation system. And scalability, for we are using KNN, so the scalability is a bit compromised, because the time complexity for KNN base is big of n notation. So if the system has a lot of bases, then it tries to go through all, and the latency a bit falls down. So the future works that we are planning is to integrate multi-camera, and also improve system in underlight condition when the processing becomes robust. Also, we are using we will be planning to use GPS for proper tracking, and scalable face recognition system in order to properly navigate through all the faces, so that the user can get a better experience. So in conclusion, we can say that Drishti is a real-time multimodal system that helps in assistive system to improve navigation for visually impaired. It achieves a high accuracy and low latency at a very low cost. Overall, it demonstrates the potential of edge AI assistive technology, and has a huge scope in coming days. Thank you. Any question, ma'am?
Junali ma'am, any questions?
Yes. So I just have one question for you. Like, you are repeatedly claiming that your model is going for low latency. So, do you have any quantitative result analysis for it?
Yeah, so currently we tried to find out for the latency thing, is that the latency currently is 25 under 25 millisecond.
So, how you are measuring it?
So for the latency thing, we in order to we at first run a Python script in order to compute how the computation is working. So we cross verified it with two more Python script, that whether the existing latency that we got is correct or not.
No, no. Your the overall model is having so many pipelines, right? It's a multi-pipeline structure. Because you are using the video detection, you are using the object detection, you are using the audio also, and then your end result also in form of audio and video, as you said. So how, like, your so latency will be what from the beginning to the end, the total
Yes,
thing,
yeah,
right? So
yeah,
how
yeah.
you are calculating with just a simple script?
So it's like we are latency similar in if we talk simply, then we are calculating that after we are capturing the image, then we are processing, then how much time it's taking to process and give the output
Mm-hmm.
in that manner we are
Okay.
calculating.
Okay. Same way you are going for audio, video, and everything.
Yeah.
So have you compared your work with any other similar works? There must be having some similar type of work. May not be completely same, but similar work must be there in the
Yeah.
Yeah. So have you compared anything?
Yeah. So we compared it with some of the existing model. So there was like for example, we compared with one of the paper. So paper that was not totally same as our, because it was just a vision based model, and the we found it that later for that it the time
Yeah, that I
yeah.
understood. That I completely got your point. So, I'm asking from the latency perspective.
For latency perspective, there was no any proper quantified data that it was using. It was this time.
Okay, okay. So they have not given any latency
No,
data in the
no,
paper.
no, no, ma'am, no, ma'am.
Okay, okay, okay. Thank you.
Thank you, ma'am.
Okay, so let's move on to the next presentation. So our next presenter is Sabarishwaran V, who's presenting his research titled as Securing E-commerce with Blockchain and Smart Contracts. So Sabarishwaran, are you there in the meeting?
Yes, ma'am. Yes, ma'am. Yes, ma'am. Good morning.
Yes, good morning. So I'll stop sharing. You can start. You have 8 minutes to present yourself.
Okay, ma'am. Sure.
Yes. Please don't exceed that time.
Okay, ma'am.
Yeah. Can you share your screen?
Yes, ma'am. I think I'm facing some network issue, ma'am. Just a minute,
Okay,
ma'am.
so what we can do is I will proceed to the next presentation. Till then, you solve the issue.
Okay, sure, ma'am. I will proceed to the next presentation, ma'am.
Yes,
Yeah,
so
okay, ma'am.
next we have Madhu Sunkanur. Are you there in the meeting?
Yes, ma'am.
Yes, so she is here to present her paper titled as Smart Handheld Oscilloscope with Integrated Processing for Real-Time Signal Analysis. So you can share your screen.
Is my screen visible?
Yes, it is visible. You can start.
Good afternoon and all. Today I'm going to present my paper Smart Handled Oscilloscope with Integrated Processing for Real-Time Signal Analysis. So in modern electrical and system, it is very important to measure the signals at a different points because sensitive components can cause frequent variation. So continuous monitoring is required to ensure the proper system performance. However, most signal measurements are currently done using the traditional oscilloscope in laboratories. These devices are bulky and not suitable for field use as they require transporting the system to the lab. To overcome this limitation, a portable oscilloscope can be used, which allows the real-time signal measurement directly at the location. A portable oscilloscope is a compact and a battery-powered device that display the voltage signals in the form of waveform. In this work, we have developed a portable oscilloscope using the ESP32 microcontroller and a TFT display, providing a cost-effective and efficient solution for real-time signal analysis. Next is the problem statement. Traditional oscilloscopes are bulky, expensive, and not portable, which makes them unsuitable for on-field diagnosis and quick signal analysis. In most cases, signal measurement requires taking the system to a laboratory, which is the time-consuming and not always practical. Also, students, hobbyists, and a field engineer often do not have the access to such expensive equipment for basic waveform monitoring. Therefore, there is a need for a compact and a battery-powered device that can visualize the electrical signal in real time. The main challenge is to design a cost-effective, easy-to-use, and portable oscilloscope that can effectively analyze the low-frequency signal. The main objective of this work are to design a compact battery-powered portable oscilloscope and to capture and display the real-time analog signal and to analyze the different waveform types such as sine, square, and triangular signal for basic signal analysis. The figure shows the block diagram where we use the ESP32, which acts as a main controller, which processes the input signal, and the signal is dispatched on the TFT screen, and push button are used for the user controller. The system is powered using a lithium-ion battery and with a buck converter for a voltage regulation. And the other figure shows the hardware prototype of the developed portable oscilloscope. Next, let us come to the working. The working of the system starts with the input signal, which is applied to the circuit. First, the signal passes through the voltage divider, which reduces the voltage to a safe range for ESP32. For AC signal, a DC offset is added to shift the waveform above the zero so that it can be properly read by the ADC. The ESP32 then samples the signal using the 12-bit ADC. This means that it takes the voltage reading at a regular interval of a time and convert them into a digital values. These values are then stored and processed inside the microcontroller. Then the data is mapped into the screen, which is the TFT, and displayed on the TFT screen using the SPI communication. And when we come to the result, the developed oscilloscope operates well within its design specification and provides the reliable performance. It accurately captures and displays the different waveform such as sine, square, and triangular waveform, which is shown here. And the system supports input voltage up to the 16 volts and can effectively track frequency up to 5 kilohertz with minimal distortion. Additionally, the display remains stable within a smooth refresh rate and even during the continuous operation. So overall, we successfully developed a portable oscilloscope which gives a real-time waveform display with a good accuracy. And since it is a compact and a low cost, it can be easily used for the practical application. Thank you.
Okay, so just a simple question from my side. What you can you tell us some of the practical applications, real time example, giving real time examples?
So we can, for example, an engineer student who is studying in electrical, they have to use for a school purpose or a lab. We can use the oscilloscope for measuring the real time to see or to check whether waveforms like hobbyistics or if you want to measure any instant waveform of a circuit, we can use the model.
Okay, thank you.
Okay, Sabarishwaran, are you ready? Is your issue solved, Sabarishwaran? Okay, so I think yes, he's there.
Yeah, ma'am, can you hear me, ma'am?
Yes. Is the issue resolved?
Yes, ma'am. Yes, ma'am.
Okay, so you can share your screen.
Okay, ma'am. Ma'am, the screen is visible, ma'am.
Not yet. Wait. I think he went. No, the screen is not visible.
No, no, ma'am. Ma'am, now it is visible, ma'am.
Yes, it is visible. You can start.
Okay, ma'am. My research is securing e-commerce with blockchain and smart contracts, ma'am. I'm honored to present our research title, Securing E-commerce with Blockchain and Smart Contracts. This work was conducted alongside my colleagues from the Department of CSE at Akshay College of Engineering Technology, Coimbatore, India. Our research focused on solving the trust and security gaps in model digital marketplaces using the decentralized technology. The e-commerce industry is booming nowadays, but it relies only on the centralized database. This creates a single point of failure. If a central database is hacked, the customer data and the transaction history can be tampered with. Currently, we face three major issues: a lack of transparency, important origins, and a risk of fraudulent transactions. Our goal was to build a system where data is not just stored but cryptographically secured, and then it is verifiable. We proposed a hybrid architecture. A common criticism of blockchain is that it will be slow for higher frequency trading. To solve this, we proposed a hybrid architecture. We used a three-layer design. The percentage layer uses the HTML5 and Bootstrap, and the logic layer uses PHP to handle the daily business activities, and the data layer uses combination of MySQL. The Ethereum blockchain is used for security purposes. This balance ensures that site remains fast while becoming unhackable in its code transaction logic. This is a proposed architecture, ma'am, where the PHP is a front-end layer, and we use a MetaMask to integrate blockchain within it. The blockchain layer will handle the security, and the backend layer will store the entire database in MySQL. The blockchain integration framework. How does the integration work? We don't put every single click on a blockchain, as that will be too expensive and slow. Instead, we're using selective recording. When a critical event occurs, like a payment confirmation or a shipping update, a cryptographic hash is generated. We include just only the hash to the blockchain. The system implementation, the front is developed with Bootstrap for responsiveness, and we use PHP statements to prevent SQL injection and bcrypt for password hashing, and we use blockchain for solidity contracts, and we use automatic inventory validation, which was widely used in the e-commerce to help to balance the stock levels. We developed a deep queue network. We had an active line as a defense. AI-based fraud detection. We utilized a deep queue network. This model monitors the real-time features like transaction frequency, IP changes, and card value anomalies. By training the agent, we will achieve 90% accuracy rate in detecting fraudulent login. While comparing to the performance evolution, we tested our system against the traditional e-commerce setups. While the hybrid model adds a slight latency of about 1.8 seconds due to the blockchain integration, the security benefits massive. Our response time stayed under 800 microseconds. Most importantly, the resolution time is slow. With a blockchain audit, it takes 22 minutes to the proof is immutable and immediately available. To conclude our research proves that a hybrid blockchain web approach provides the best of both worlds. The spend of traditional web apps and the trust of decentralization. Moving forward, we plan to implement scaling solutions to reduce transaction costs further and explore. Thank you for the time. My suggestion is to we will enhance the interoperability across multiple blockchain networks and like a consortium network, which means the individual or a group of organization have to own the blockchain and they will integrate within the site. Thank you for this opportunity, ma'am. I am now open to your questions, ma'am.
Okay. Ma'am, do you have any questions?
Yeah, so I just want to know what are the encryption algorithms you have used?
Ma'am,
For-
deep QNet, first one is, ma'am, ma'am,
Yes.
can you hear me?
Yes, yes. See.
Ma'am, we use a deep network, ma'am, which will analyze the user data like a transaction, IP, and it learn from itself. And if any detection like a fraudulent behavior, it will alert to the admin, ma'am.
Okay, so have you compared it with any other encryption algorithm available? Then like have you done any comparison so that you can know that this is working better than the other
Ma'am,
algorithms?
because it's a reinforcement algorithm, it makes a trial and error, ma'am. It takes every transaction trial. If it is possible, if it is succeed, then only it will proceed, ma'am, or else it deletes the event, ma'am.
Okay, okay, thank you.
So thank you, ma'am. Thank you for this golden opportunity, ma'am.
Yeah.
One second. Okay, so our next presenter is Hasina Islam. Are you there in the meeting, Hasina? Ma'am? Okay, I think let me check once. Okay, she is not there in the meeting, I guess. Let's proceed with the next presenter. So for the next we have Bin Pham Nguyen Than.
Yes, I'm here.
Yes. So, are you ready with the presentation?
Yes, let me share my
Yes.
screen.
So you can start. You have a time limit of 8 to 9 minutes. You have to finish within it.
Yes, can you see my screen?
Yes, it is visible. You can start.
Yes. Hello everyone attending the conference. I'm Bình Phạm Nguyễn Thanh from the University of Information Technology, Ho Chi Minh City, Vietnam. And today I will present our research title, The Interaction of Convolutional Structure and Can Bottleneck in
Excuse me, please. Your sh screen has stopped sharing. Like it is paused. The presentation was not visible.
Let me say again.
Yes,
Can
yes.
you see that?
Yes, now it is visible. You can start it.
Yeah,
Yes.
I will continue. Today I will present our research title, The Introduction of a Convolutional Struct and Can Bottleneck in UCAN Architect. The outline of the presentation includes the introduction, methodology, experiment, result, and conclusion. First, the introduction regarding to the universal approximate theorem. And this is the theorem is the foundation of the today neural network. An artificial neural network with at least the one hidden layer, affinity number of neurons, and any continuous function. Um, and we can approximate any continuous function given a appropriate condition on the activation function. Similarly, for continuous function, we have the Kolmogorov-Arnold theorem. By this theorem, um, that if a multivariate continuous function, we we can we can be rewrite a infinity composition of the continuous functions of a single variable. By this theorem, the CAN network was developed, and this idea has been implemented in the bottleneck, the part of the UNet to form the UCAN, while the encoder and decoder parts remain unchanged. And in this study, we analyze more detail about the interaction between the new bottleneck and the existing encoder and decoder. The evaluation includes the data augmentation, the number of convolutional layers, and the types of segment image data. Next is the methodology. And so to represent a function y equal f, if we have a feature x1 to the xn, first we pass the input feature to the univariate functions, then we sum them up and pass the sum through another function and repeat that. And the phi function used in CAN here typically a B-spline with the control points. We can freely approximate their representations to become the activation functions and making our model smoother and more efficient. And this integrated into the UNet at the token while the encoder and decoder remain the same. After receiving the feature from the encoder, the feature are flattened and passed through the token module, and the outputs are sent to the decoder to generate a segmentation region. And to better understand the impact of the encoder and decoder on this new bottleneck, in this study we conduct the following experiment. First, applying the data augmentation to analyze the generalization capability. Next, varying the number of the features in the convolutional layer in the encoder and decoder to evaluate the feature processing capability of CAN bottleneck. Finally, we answer the question, how do the encoder and decoder affect the performance across different types of segmentation data? Next part is experiment. And experiment were conducted on 4 different datasets, including BUSI, GLASS, the CVC, and the Kaiser instrument. And here the training parameter setting and the data argument techniques we use. The next part is our results. There, the result on our four datasets is include feature channel setting, the number of convolutional layer, and the data augmentation. And this chart had been redrawn based on previous table. And from that, we can see the feature channels increase channels improves accuracy, but with diminishing returns. About data augmentation, strongly improves performance, especially for the smaller model, reduce the big gap between the small and large models. About the model complexity, fewer convolutional layers reduce complexity with the little accuracy loss. The depth is more important than channel size in low capacity model. And further experiment we conducted on the BUSI and CVC datasets to see if we should focus more on the encoder or the decoder. And as we can see, in all cases, reducing one layer in the encoder gave the better result than reducing one layer in the decoder in the BUSI dataset. And on the CVC dataset, the opposite trend is found where reducing the layers in the encoder, in the decoder, results in a better performance. And from this, we can make another observation. For the BUSI datatest, it's better to focus on the decoder reconstruction stage. For the CVC dataset, it's better to focus on the encoder. A reason may be because ultrasound images are formed by capturing the reflected sound waves rather than direct visual information. So making the reconstruction process more complex. Its constrained CVC images are captured directly. So focusing on understanding the image leads to better segmentation performance. And here is some illustrative result on the image segmentation process. This is on the breast ultra image dataset. And this is the CVC dataset. Finally, a conclusion. In this study, draw the several key findings from the UCAN model, including increasing the feature channels, improve the accuracy, but only up to a point. Reducing convolutional layer lowers model size with a least lot in performance. And the data augmentation has the smaller model perform close to large model. Depend on the dataset. Optimal encoder and decoder design depend on the data types. And finally, the best performance comes from the balancing model design, the channel size, and augmentation, not just the model size. And that's my presentation. Thank you for listening.
Okay, so just a couple of questions from my side. Can you tell some of the real-time applications of your work?
Application for this viewers, maybe we can reduce the parameter of the model to can make it to the edge device because some the deep
No,
learning
that I
model.
understood. How to get the optimized performance, that is okay. That is absolutely correct. But I'm asking, in what are some of the real-time application scenarios where such type of models can be used?
Can you rephrase the question?
Can you tell me some of the real-time applications where the models which you have devised can be used? Your proposed approach can be used.
Yes, the application of my model can be used. Um,
So there,
in,
so there are many real-time applications, right? Where we are using this deep learning models, artificial neural networks. So can you name some of them?
some of the deep learning models.
Okay, have you compared your work with other
I
works?
guess. Actually, I just compare with the original paper. The original paper is from for this row in our result. And I compare with the previous work when we have additional data argument and have and it can make my model have a higher accuracy.
Okay, so your model got better accuracy than the original work, right?
Yes.
Yeah, yeah. Okay, okay, I got it. Thank you, thank you.
Yes, thank you.
Thank you for the presentation. Moving on to the next presenter. We have Wani Zahida Mohammad Subari with the paper titled VD and Cultivated Rice Classification During Harvesting Stage Using YOLO V8.
I'm here.
Do you have Vani? You can start your presentation now.
Right. Can you guys see my slide?
The screen share is visible, but the slides aren't. I guess you are not sharing your presentation yet. Yes, it's visible now.
Right. Is it? Right. Right slide. Good evening, everyone. So my name is Wani Zahida, and today I will be presenting research paper titled Woody and Cultivated Rice Classification During Harvesting Stage using YOLO V8. First of all, I would like to explain why this problem is important. As we all know that rice is one of the most important food sources in the world. As the world population continues to grow, the demand for good quality rice also increases. However, one major problem in rice farming is weedy rice. Weedy rice competes with cultivated rice for water, nutrition, sunlight, and space. Because of this, it can reduce rice yield and also lower rice quality. Another challenge is that weedy rice often looks very similar to cultivated rice, especially during the harvesting stage. This makes manual identification difficult and sometimes inaccurate. And why I'm choosing harvesting stage because most previous studies focus more on early growth stages, such as the tertiary stage. And in the study, the harvesting stage was selected because the visual differences in the grains are clearer and visible, and the stage is important for sorting, quality control, and reducing the further spread of weedy rice caused by seed shattering. Next, regarding the methodology of this study, this research consists of 3 phases. In phase 1, images were collected and prepared. The images were obtained from field sources and online sources because harvesting stage images were quite limited through online. So field data collection was important to build a more relevant data set. The images were then divided into 2 classes, which are weedy rice and cultivated rice. For the field data, the images were collected in Kedah, Malaysia during the harvesting season. The data collection was carried out with support from Muda Agricultural Development Authority, or known as MADA, which is one of the agricultural association in Malaysia. And the images were taken using the normal mobile phones using natural lighting conditions with guidance from an expert. And in phase 2, images pre-processing and model development were carried out. The images were labeled using bounding boxes. The training ratio was set and data augmentation was applied. These processes were done using RoboFlow. The augmentation methods included horizontal flipping, grayscale conversion, brightness adjustment, and noise addition. So these steps definitely help to improve the dataset diversity and support better model generalizations. In phase 3, The model was trained, tested, and validated. The final output was the classification result, which identifies whether the rice is weedy rice or cultivated rice. Next, regarding the initial experiments result. First, result. In the early experiments, I compared three YOLO V8 model sizes, which are nano, small, and medium. I also compared two dataset speed ratios, which are 70-20-10 and 80-10-10. All models were first trained using the same default settings, which were 100 epochs, batch size 16, and learning rate 0.01. From these experiments, the 80-10-10 split gave better results compared to 70-20-10 split. And on the right, we can see that based on the graph, the training loss and validation loss decrease over time. This means the model is improving and making fewer errors during training. And at the same time, precision, recall, and map increase, which shows that the model becomes better at detecting and classifying the rice correctly. So that's why among other models, the YOLO V8 small model with the 80-10 split showed the best overall balance. After selecting the best initial model just now, I continued with epoch tuning to improve the model performance. The selected model was the YOLO V8 small model with the 80-10-10 split. Then the model was retrained using different numbers of epochs. Based on the result, the best performance was achieved at 200 epochs. At 200 epochs, this shows that increasing the number of epochs helped the model learn better and improve the classification results. However, after that point, the performance slightly decreased. This suggests that 200 epochs was the best point because it gave strong performance without overfitting. And to be concluded, this study shows that the harvest stage rice classification using YOLO V8 is feasible and effective. This model produced some strong result and showed good potential for practical use. In addition, a simple and lightweight web-based prototype was also developed to demonstrate how the model can be applied in practical way. So basically, users can upload the rice images and receive classification result quickly. And the prototype was also validated by the expert. So the impact of this study is that it can support precision agriculture and improve the rice quality management. And for the future work, more images should be collected, especially for cultivated rice, to create a more balanced data set. Collaboration with agricultural institutions can also help strengthen future data collection and improve model performance. That's all for me. Thank you very much.
Okay, so I just have one question for you. That is why you have used YOLO V8 model. So when we have already some other versions like YOLO V9, V11, so why you didn't use those and why you went for choosing the YOLO V8?
Because YOLO V8 was chosen because many previous studies show that it performs well in object detections, including agricultural applications. So it is known for having a good balance between speed and accuracy. So that's why I pick YOLO V8 as one of the model that I want to use.
Have you used YOLO V9, V11 or other versions of YOLO and checked whether this is giving better accuracy than it, or you have simply from the literature review you have decided that YOLO V8 will be good?
From literature review.
Okay, okay. Okay then. Thank you.
All right.
Thank you for the presentation. I would just like to call out the presenter who was previously absent, Sonali S. Gaikwad, if we have her in the session right now, or any of the co-authors of the paper. Well, I guess no one is present in the session, so that brings us to the end of the session. And I sincerely thank all our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for you all. On behalf of the whole team, we thank you for your support during this 11th version and all the previous 10 versions of the conference, and we will be happy to have you in the 12th version in 2027. All the presenters would be getting their digital certificates through email within 2 working days, and the publication will be live within 7 to 8 months. So kindly cooperate with the team of ICTIS 2026. I would also like to thank our session chair for chairing this session. And this is a small token of appreciation on behalf of the whole team of ICTIS and Global Knowledge Research Foundation. Thank you so much for your valuable presence, ma'am.
Thank you.
Yes.
Thank you. Thank you.
Thank you. Now, I would just request you all to please turn on your cameras for a quick snapshot of this virtual conference. And we'll wait for 5 more seconds. Okay. Thank you so much, everyone.
Thank you.
Thank you. See you all in the next session.
Thank you, ma'am.
Thank you.